Hello everyone. Here we'll be solving the CAT 2020 quant section, looking at the slot 1, all the questions. So this is a video presented by the group 100 Percentiler. We are a group of people who love maths as a subject, and we have an active Facebook group which is CAT Quant by 100 Percentiler. So anyone can go there and solve questions. We have a lot of good solvers in the group. So this is something about me. I'm Calcutta and IIT Kanpur grad, and I have given CAT twice, and I was a 100 percentiler in Quant DI section for the first when I gave the CAT first time. So here we'll be looking at all the 26 questions solutions in detail, so that every student is able to understand like all the concepts which are being tested here. Okay, so let's get started. The first question is, how many three-digit numbers are there for which the product of their digits is more than 2 but less than 7? So we are given here that the product is greater than 2 but less than 7. Obviously the product has to be an integer, and therefore the only possible values of that product are 3, 4, 5 or 6. Now, as 3 is a prime number, it could be only written in 3 cross 1 cross 1 as a product of 3 integers. There is no other way to write 3 as a product of 3 integers. Now, using this 311, we can have 3 possible numbers: 311, 131 or 113. Or there are 3 C1 ways to choose one of the 3 positions which will contain the digit 3. Now 4 can be written as 2 cross 2 cross 1 or 4 cross 1 cross 1. Once again, just like the previous case, the 4 cross 1 we'll have 3C1 solutions, and here the distinct digit is 1, so again we will have 3C1 solution. 5 is very similar to 3, so we can write it as 5 cross 1 cross 1, and again there will be 3C1 possible numbers. 6 can be written as 6 cross 1 cross 1 and 3 cross 2 cross 1. Now this is similar to previous cases, and therefore there are 3C1 such numbers, but 3 cross 2 cross 1, there are 3 factorial ways to place 3 distinct digits into 3 positions. So total number of 3-digit numbers possible here is given as 3C1. This is coming 5 times plus 3 factorial, which is 21. So 21 is the required answer here. Going to the second question, here we are given f of f plus 5 plus x is equal to f of 5 minus x for every real x, and fx equal to 0 has 4 distinct real roots. We have to find the sum of those roots. So if fx has 4 distinct roots, then we know that if a, b, c and d are the roots, then we can write the function in this particular factored form. Now we are given that f of 5 plus x equal to f of 5 minus x. So simply putting this 5 plus x and 5 minus x into this particular form, we get 5 plus x minus a, 5 plus x minus b, and so on, which is equal to 5 minus x minus a, 5 minus x minus b, and so on. Now if these two polynomials are equal to each other, the sum of the roots of this particular polynomial should be equal to sum of the roots of this particular polynomial, and therefore we can see that the first root here is a minus 5 plus b minus 5 and so on, which this should be equal to, the root here is a minus 5 but with a negative sign, minus b minus 5 minus c minus 5 and so on. So we are actually having 2a plus b plus c plus d minus 2 into 4 times we have 5 here. So the sum here is nothing but 20. So 20 is the required sum here. Here we are given that Vidu invested 10,000 at 5% simple interest rate, and exactly after 2 years, Joy invested 8,000 at 10% simple annual interest. So if 10,000 is getting invested by Vidu, let's call it 10k. This after 2 years, so this is t equal to 2, this is t equal to 0. This after 2 years will become, so in 2 years, if the single year interest rate is 5%, then in 2 years, 10% will be gained, as it is a simple annual interest. 10% of 10k is 1k. So we will have a total value of 11k after 2 years. Now Joy is investing at t equal to 2, which is 8k. Now let's say going n years ahead for both of them, after t equal to 2, Vidu will have 11k plus he is gaining 0.5k per year. So this is 0.5n. Now for Joy, he is gaining 10% of 8,000 because 8,000 is the principal balance here. So 10% of 8,000 is 0.8. So after n years, it will be 0.8n, that will be the gain. So equating these two, we get 0.3n is equal to 3k. And therefore, n is nothing but 3 upon 0.3, which is 10. But this n is after t equal to 2. So we are asked how many years after Vidu's investment, that is after t equal to 0. Therefore, 10 plus 2 equal to 12 years is the required time frame here. Looking at the fourth question, we are given that a train traveled at 1/3 of its usual speed and hence reached the destination 30 minutes after the scheduled time. So let's say it normally takes t hours to complete its journey, but now it's taking t hours plus 30 minutes. 30 minutes is nothing but 0.5 hour. And the total distance it covers is d, but the speed here is 1/3 of the usual speed, which is v upon 3. Now on its return journey, the train initially traveled at its usual speed of 5 minutes. So now here we know that d upon v is t. This is for the usual case. Like when it's traveling with its usual speed v, it reaches in time t. So if we solve this now, so equating d upon v value from these two equations, we have 3t plus 1.5 equal to t. That's actually 3 plus 0.5 upon 3 equal to t. So t plus 0.5 is equal to 3t, and therefore t is equal to 0.25 or 15 minutes. And therefore we know that d upon v is nothing but 15 minutes. Now we are given for the return journey, it travels for speed v for the 5-minute period. Now as it completes the total journey in 15 minutes, it will complete 1/3 of the distance in 5 minutes. Then it is stopping for 4-minute period. Now the percentage by which the train must now increase its usual speed so as to reach the destination at the scheduled time, we have to find this. So let's say the speed here is Vn, this is the new speed, and we have to travel the rest 2 upon 3 distance in this 6-minute period. So the new speed Vn required is 2d upon 3. Now 6 minutes we have to write in hour because all our analysis till now has been in hours, and therefore this become 20d upon 3. Now the initial speed we already know is v equal to d upon 15 minutes, which is 0.25 hour, which is 4d. Therefore the increase in speed required here is 20d upon 3 minus 4d upon 4d. this is nothing but 5 upon 3 minus 1, which is 2 upon 3, which is 67%. So B is the correct answer here. So just to note here, we only used a very simple formula. Speed is equal to distance upon time. No complex things, just use the simple basics. Okay, so looking at the fifth question, this is on logs. So we are given that log of 5 to the base 4 is equal to log of y to the base 4 multiplied by log of root 5 to the base 6, and we have to find y. Now here we'll be using the property log of x to the base y is nothing but log of x upon log of y, both to the base of some common base. Let's call it c. So this is like a property for logs. Now we have here, we can write this as log 5 upon log 4 is equal to log y upon log 4 multiplied by log of root 5 upon log of 6. Now log of root 5 is log 5 raised to power 1 upon 2, which can be written as 1 upon 2 log 5. So this is nothing but log y upon log 4 multiplied by 0.5 of log 5 upon log 6. We cancel out log 4 with log 4 and log 5 with log 5. So we are left with log y is equal to 2 log 6, which means y is 6 squared equal to 36. Okay, looking at the sixth question here, we given that find the number of real valued solutions of the equation 2 raised to power x plus 2 raised to power minus x is equal to 2 minus x minus 2 whole square. Now the first thing we notice here is for 2 raised to power x plus 2 raised to power minus x, this can be written in the form of k plus 1 upon k, with k being equal to 2 raised to power x. Now for k plus 1 upon k, we know the minimum value as 2. So if the minimum value of this particular expression is 2 and the right hand side value we are given is 2 minus x minus 2 whole square, this is obviously always greater or equal to 0. Therefore, this whole expression is always less than or equal to 2. Now, if the minimum value of LHS is 2 and the right hand side equation can only be less than or equal to 2, therefore, both of them have to be equal to 2. Now, for this particular expression to be equal to 2, we know that x has to be 2, as this particular term will become 0. Therefore, now x equal to 2, we have to also satisfy on the left hand side. So 2 raised to power x plus 2 raised to power minus x. This should be equal to 2 as well, because we took the right hand side value as 2. But 2 square plus 2 1 upon 2 is clearly not equal to 2. And therefore, there is no possible solution, and therefore 0 is the correct answer here. Okay, jumping to the next question. We are given here that a straight road connects points A and B. So let's call these 2 points A, B. Car C1 travels from A to B and C2 travels from B to A. After meeting each other, so let's say they meet at a point X, and let's say the total distance is D. So after meeting each other, they take 45 minutes and 20 minutes respectively to complete the journey. So to complete the journey, A will be left with D minus X and B will be left with X. So we know that D minus X upon C1 is equal to 45 minutes, which is 3 upon 4 hours. Similarly, for X distance traveled by C2, we take 20 minutes, which is 1 upon 3 hours. Also, as they are meeting at this particular point, we know that the time taken to travel D minus X for C2 should be same as X distance traveled by C1. Now, if we take the ratios of D minus X upon X, we have C2 upon C1. And if we divide these two equations, we again have d minus x upon x as 3 c1 upon 4 upon c2 upon 3. Now equating this to c2 upon c1. So basically we are equating these two equations here. This becomes 9c1 upon 4c2 equal to c2 upon c1. And we therefore get c2 equal to 3 upon 2 c1, which is 1.5 times the speed of c1, which is given out which is given to be 60. So 1.5 into 60 becomes 90. So 90 is the required answer here. Okay, looking at the next question, we are given here a, b and c are three positive integers such that sum of a and mean of b and c is 5. So a plus sum of mean of b and c. So mean of b and c is what? B plus c upon 2. This is given to be 5. Similarly, we are given that sum of b plus mean of a and c is equal to 7. Now just simplifying these and eliminating c, so we can subtract this particular equation from the first one. We get a minus b plus b minus a upon 2, nothing but minus 2. So this becomes a upon 2 minus b upon 2 equal to minus 2, and therefore a minus b is nothing but minus 4. Now we have to find the sum of a and b, not the difference. We have to find the sum of a and b, but we are only given two equations and we have three variables. So what else we have? That a, b and c are three positive integers. So we know that a has to be greater or equal to 0 or greater than 0, in fact, because they are positive integer. Therefore b minus 4 is greater than 0. Therefore b is greater than 4. So the minimum b value can only be 5 here. Now let's say let's look at the first equation here, which is 2a plus b plus c. So we are looking at this particular equation here. This is nothing but equal to 10. Now let's say for b equal to 5, we know that a will be equal to b minus 4, which is nothing but 1. So let's put all these values here. C is nothing but 10 minus 2a minus b, which will become 3 in this case. Now let's take the next possible value, b as equal to 6. Then a will be equal to 2 and c will be equal to 10 minus 2 into 2 minus 6, which is 0. But this is not a possible value because c also has to be a positive integer. Therefore this is the only possible set of values here, and therefore the sum is equal to 6. Okay, here we have been given that 4096 raised to power 7 plus 4 root 3 is the value of x. Then what is the value of what is the expression for 64? So clearly the first thing which we notice here is 4096 is nothing but 2 raised to power 12. So we are given here that x is nothing but 2 raised to power 12 multiplied by 7 plus 4 root 3. Now we have to find an expression for the number 64, which is 2 raised to power 6. Now if we look at the four options here, we can see that there are some very frequently used values here. So there are only two possible numerators, in fact, x raised to power 7 and x raised to power 7 upon 2. So x raised to power 7 is nothing but 2 raised to power 12 into 7 is 84 into 7 plus 4 root 3. Similarly, for 7 by 2, we get 2 raised to power 42, 7 plus 4 root 3. Then there are various possible values of denominators, the most frequent being x raised to power 2 root 3. So this will become 2 raised to power. So 2 into 12 is 24. And we are multiplying by root 3 inside. So 7 root 3 plus 12. Similarly, there is x raised to power 4 root 3, which will be nothing but 2 raised to power 48 and 7 root 3 plus 12. Now, if we compute the values of various expressions, so let's look at b first. We have x raised to power 7 upon x raised to power 4 root 3. So if we just use the powers here, this will be x raised to power 7 minus 4 root 3. And we know that 7 minus 4 root 3 multiplied by 7 plus 4 root 3 will be 49 minus 4 root 3 square, which is 49 minus 48. And we are obviously left with 12. So this will become 2 raised to power 12. But we need 2 raised to power 6, and therefore we just want to do x raised to power 7 upon 2 upon x raised to power 4 root 3. So let's look this particular. So now let's compute other expressions here. So let's look at C. This is x raised to power 7 upon 2 upon x raised to power 2 root 3. This is x raised to power. So we have already computed these here. This is this particular expression and this particular expression. So this becomes x raised to power 42, 7 plus 4 root 3 minus 24, 7 root 3 plus 12. Now the main thing here is we want to eliminate this root 3. So if we check here, 42 into 4 minus 24 into 7, this will be 168, and this will also come out to be 168. So we have been able to eliminate the root 3 here, and we are left with the power x raised to power 42 into 7 minus 24 into 12. So we can compute this. This will come out to be x raised to power 6, which is 64, which is a required number. Therefore, C is the correct answer here. Now here we are given the mean of all the 4-digit even natural numbers of the form AABB, where A is greater than 0. Now, as it's an even number, we know that B can only take the values 0, 2, 4, 6 or 8. Also, A can only take the values 1, 2 till all the values till 9. Now, to find this particular mean, what we do is we first calculate the mean of AA00 and we calculate the mean of BB. So basically the sum of these two means will be equal to the mean of the final expression. Now how we calculate this? This is 1100, 2200 and so on till 9900, all being equally likely. Therefore we simply add them up and we get, so the sum of the digits from 1 to 9 is 45. So we do a 45 carryover and this becomes 49. Now as there are 9 possible values here, the mean would be nothing but 49500 divided by 9. This becomes 5500. Now for BB, we know that only possible values are 0, 0, 2, 2, 4, 4, 6, 6 and 8, 8. We find the sum here, 4, 6, 12, 20, 8, 14, 18, 20, 22. Now as there are 5 possible values here, 220 divided by 5 is nothing but 44. Therefore 5544 is the required mean here. The number of distinct real roots of the equation x plus 1 upon x whole square minus 3 into x plus 1 upon x plus 2 equal to 0. So very quickly we can write this as k square minus 3k plus 2 equal to 0, where k is nothing but x plus 1 upon x. Now k square minus 2k minus k plus 2 equal to 0. This is k minus 2 minus 1 is equal to 0. So we have already seen in a previous question that this particular form has to be greater or equal to 2. Therefore, the minimum value of k is 2 and therefore it cannot be equal to 1. Therefore, there is only one possible value, k equal to 2 here, which is only possible for x equal to 1. Therefore, 1 is the required answer here. Okay, so a person spent 50,000 to purchase a desktop computer and a laptop computer. So let's say he spent x on desktop and 50 minus x on laptop. Now he sold the desktop at a 0.2 at a 20% profit. So let's compute the profit here. This is 0.2x because the profit will be on the purchase cost for desktop. Similarly, a laptop at a loss of 10%. This is minus 0.1 into 50 minus x. Now overall he made a profit of 0.02, that is 2% on overall money, that was 50k. So just solving this particular equation, we have 0.3x equal to 10. This is actually equal to 1k. So 1k plus 5k is 6k. X is 6 upon 0.3, which is 20. So the purchase price in rupees for the desktop is nothing but 20,000. Going to the next question, we are given here that among 100 students, x1 have birthdays in January, x2 have birthdays in February, and so on. If x0 is equal to max of x1, x2 and so on till x12, we have to find the smallest possible value of x0. So we take the worst case here. As there are 12 different months, the maximum possible value in each month, if we equate them basically, would be, let's say 100 divided by 12, and it will be 8 point something. So basically 8 into 12 is 96. So even if all the 12 months have got 8, all the 12 months have at least 8 students, we still have to have 4 months with 9 students. So the minimum possible value for x0 has to be equal to 9, because if the minimum value of x0 is less than 9, let's say 8, then we need to obviously put all the 8 in 12, which is 8 into 12, 96. We would still be left with 4 students, and therefore 9 is the required answer here. Okay, so here we are given 2 persons are walking beside a railway track at a respective speed of 2 and 4 km per hour. So let's say A is moving at 2 km per hour and B is moving at 4 km per hour. Now a train comes from behind them and crosses them in 90 and 100 seconds respectively. Now a train can only cross a particular person, let's say, so it starts when the man reaches this particular point, and it crosses when the man reaches this particular point. So if the length of the train is x, then we know here that x upon speed of the train minus the speed of the person has to be equal to the total time which is taken to cross the train, which is 90 upon 3600. We divide by 3600 because we are taking everything in hour here, and the time here is given in seconds. Similarly, for the second person, x upon v minus 4 becomes 100 upon 3600. Now dividing these two equations, we get v minus 4, v minus 2 upon v minus 4 equal to 10 upon 9. this is 9v minus 18 equal to 10v minus 40, and v comes out to be 22 here. Now what we have to find, the time taken by the train to cross an electric post. So electric post is non-moving post, and therefore the total time taken by the train to cross this electric post would be nothing but x upon v, where v is the speed of the train, because the speed of the pole is 0. Now x upon v we have to find, and we already know v as 22, so we can simply put v in any of the equation and get the value of x. So x is equal to 90 upon 3600 into v minus 2, which is 20. So this becomes 0.5, and therefore x upon v is 1 upon 44. Now we have to find this in seconds, but this is 1 upon 44 r. So multiplying by 3600, we get the required answer in seconds, which is nothing but 81 point something. So since we are not given the exact value here, we will take the most closest one, which is 82. Now here we have to find how many distinct positive integer valued solutions exist to this particular equation. So whenever we have an equation of the form a raised to power b equal to 1, we know that there could be only 3 possible conditions here. Either b is equal to 0, or a is equal to 1, or a is equal to minus 1 and b is even, because minus 1 raised to power some even number is 1. So let's look at them one by one. First, this particular condition, we have x square plus minus 13x plus 42 is equal to 0. So x equal to 6 and 7. Now for the second condition, where a is equal to 1, we look at x square minus 7x plus 11 equal to 1. X square minus 7x plus 10 equal to 0, and therefore x is equal to 2 or 5. Now looking at the third one, we have to check two conditions here. So let's see, look at the first one, x square minus 7x plus 11 equal to minus 1. So obviously x square minus 7x plus 12 equal to 0, and x is equal to 3 or 4. But we also have to check whether power is even or not. So x square minus 13x plus 42 for 3 and for 4. This is 9 minus 39 plus 42. 42 plus 9 is 51, minus 13 is 12. So yeah, this is even. And now for x equal to 4, minus 52 plus 42, all the three are even, so this will be again even. And therefore there are 6 possible values here: 2, 3, 4, 5, 6 and 7. These are the possible positive distinct solutions here. The area of the region satisfying the given inequalities here. So clearly the last two inequalities are the easiest one. So let's start plotting them. So let this be y equal to 1 and this is y equal to 0. So we know that all the area has to be within these two lines. Let this be x equal to 1. Okay. The next inequality, the first one we are given is mod x minus y has to be less than equal to 1. Now for x greater than 0, x minus 1 has to be less than equal to 1. Now we plot this particular linear equation, which is x minus y equal to 1. So for y equal to 0, x is 1, and for x equal to 0, y is equal to minus 1. So if this is minus 1, this will be the equation here. Now we know the area has to be x, so we are only looking at cases of x greater than 0, and therefore we are looking at all the possible values here. and also y is greater than 0, and therefore this will be the required area here. Now for x less than 0, we know that mod x equal to minus x minus y is less than equal to 1. So this is x plus y is greater equal to minus 1. So once again, if we plot this, we'll get a symmetrical figure on the other side, and this will be the required area. Now finding the area here, this is nothing but this particular part and this particular part, and we are multiplying by 2. So this is a square of side 1 and this is a half of that square. So the area here is 1.5 in the shaded region, and we just multiplied by 2 because we have the same area here. Therefore 3 is the required area of the region here. Okay, so here we are given a solid right circular cone of height 27 centimeter. So let's have a cone here. And this is 27. Is cut into two pieces along a plane parallel to its base at a height of 18 centimeter from the base. So let's cut it here, and this is given out to be 18. So therefore obviously this is 9. Let's call this smaller and let's call this a bigger. If the difference in the volume of the two pieces is 225, the two pieces here are this piece and this piece. The volume of the original cone we have to find. Now whenever we cut a cone, we know that two similar triangles are formed here. So this particular small triangle and then a large triangle. So therefore 9 upon r has to be equal to 27 upon r, and therefore r is nothing but 3r. Now the difference in the volumes, so the volume of a cone is 1 upon 3 pi r square h. So 1 upon 3 pi r square into h minus pi r square h. So this is the area of this particular shaded part. Now we have to subtract the area of the other part as well, and this is equal to 225. So this can be written as 9r square here, and therefore this become 81 pi r square minus 6 pi r square is equal to 225. R square is equal to 3 upon pi. Now what we have to find is volume of the original cone here. So original cone volume is 81 pi r square as seen here. So this is nothing but 81 pi into 3 upon pi, which is 243. Therefore 243 is the required answer here. Okay, so here we are given a circle is inscribed in a rhombus with diagonals 12 and 16 centimeter. So let's make a rhombus first, and we have a circle inside the rhombus touching all the sides, and we are given the diagonal lengths. Now for a rhombus, the diagonals are perpendicular to each other, and also they bisect each other. So if this diagonal is 12, the half of it will be 6, and similarly this will be 8. And obviously using Pythagoras, this will become 10. Now as this particular side is, let's say side AB is tangent to this particular circle, therefore if we draw a line from the center of the circle to this particular side, it will be perpendicular to it. So let's compute the area of this triangle. This is nothing but half into this particular height, which is radius of the circle, multiplied by the base, but this is also equal to half into 6 into 8, because this is the two diagonals are perpendicular to each other. So this becomes 24, this becomes 5r, and therefore r is 4.8. Now the ratio of the area of the circle to the area of the rhombus is area of the circle is nothing but pi r square, which is, and area of the rhombus is 0.5 times the product of the diagonals. So let's make it 48 into 48. So this will become 50, 12, 16. This becomes 4, this becomes 3. Therefore, we have 6 pi upon 25 as a required ratio. Therefore, B is the correct answer here. Okay, so here we are given that leaving home at the same time, Amal reaches office at 10:15 if he travels at 8 km per hour and 9:40 am if he reaches at 15 km per hour. So let's say he travels at a speed of v, and let's say he reaches at time t for a normal speed of 8. So let the distance be x. Therefore, x upon 8 is equal to t, and x upon 15 is equal to, so 10:15 am is 35 minutes more than 9:40 am. So this will become t plus 35 minutes, which is 7 upon 12 hours. Therefore, 8t is nothing but, in fact this is minus, because obviously he's reaching at 9:40 am, so he's reaching 7 upon 12 hours earlier. So 15t minus 15 into 7 upon 12. So 7t is equal to 15 upon into 7 upon 12, and therefore t is 15 upon 12, which is 1.25. Leaving home at 9:10 am, at what speed must he travel so as to reach office exactly at 10 am? Now, if we know that t is 1.25, then we already know x as 8t, and therefore it will be 10. Now, we have to reach in from 9:10 am to 10 am, that is 5 upon 6 hours. Therefore, the speed is computed as x upon v equal to 5 upon 6. So, v is 10 into 6 upon 5, which is 12. Therefore, 12 is the required speed here. Next, here we are given a, b and c are positive integers such that a, b is equal to 432, b, c is equal to 96, and c is less than 9. We have to find the smallest possible value of a plus b plus c. Now, we clearly are given here that c is less than 9 and bc equal to 96. So, first let's factorize 96. It's nothing but 32 into 3, which is 2 raised to power 5 into 3. Now, as c is less than 9, the possible values of c could be 1, 2, 2 square, 2 cube, 3, and 2 into 3, which is 6. So, these are the only possible values here. For these values, the values of b would be 96, 48, 24, 12, 32, and 96 divided by 6 is 16. Now, for these values of b, the possible values of a, so if we use this particular first equation where ab is 432, we compute the values of a. For b equal to 96, ab cannot be equal to 432 for any integer a, and therefore no possible value here. For b equal to 48, a has to be equal to 9, and a plus b plus c can be calculated now as 59 here. Then for b equal to 24, a has to be equal to 18. Therefore, the sum of values here is calculated to be 24 plus 18, 42, plus 4, 46. We don't have to go further because the lowest option anyways is 46 here, and therefore 46 is the required answer. Here we are given that y is a negative number. Therefore, y is less than 0 such that 2 raised to power y square log of 5 to the base 3 is equal to 5 raised to power log of 3 raised to power 2. And we have to find y. So here what we'll be using, the property here is, let's say 2 raised to power log x to the base y is nothing but x raised to power log 2 raised to power y. So this is like these two values can always be interchanged. This is one of the properties of logs. Therefore, using this, we are given here that 2 raised to power y square log of 5 to the base 3 is equal to 5 log of 3 to the base 2. So this can be written as 5 raised to power y square log of 2 raised to power 3 equal to 5 raised to power log 3 2. So the base here is same and therefore the powers can be equated. Y square log 2 to the base 3 is 5 of is equal to log of 3 to the base 2. Now once again we have seen before that log x to the base y is log x upon log y, and therefore y square can be written as log 3 whole square upon log 2 whole square. Therefore y is plus minus log 3 to the base 2. Now log 3 to the base is greater than 0. Therefore y has to be minus log of 3 raised to power 2. Now this minus can be taken as a power of 3 and therefore y is nothing but log of 1 upon 3 to the base 2. Therefore A is the correct answer here. Here we are given on a rectangular metal sheet of area 135. So let's construct a rectangle. Let's call this particular side as B. We are given that a circle is painted such that the circle touches the opposite two sides. So let this be A. And it can only touch the opposite side for the longer sides. It cannot touch the shorter sides, and therefore this is the only possible way that the circle can be constructed. Obviously it can move anywhere in the horizontal line. Now said that the circle touches the opposite two sides, if the area of the sheet left unpainted, so this particular area, is 2/3 the painted area, then perimeter of the rectangle is what we have to find. Now area of the sheet left unpainted would be what? The total area of rectangle minus the area of the circle. Now if we look here, the radius of the circle is nothing but 2r is equal to a, and therefore r is equal to a upon 2. Therefore pi r square, this is equal to 2/3 the painted area. Now performing some computations here, we have pi a square equal to so a comes out to be root of 324 divided by pi, and therefore b has to be equal to 135 upon a, because the area of the rectangle was 135. So this comes out to be 135. This is nothing but 18 upon pi, and this comes out to be 135 pi upon 18. So let's simplify this a little. Dividing both the numerator and denominator by 9, we have 1 45 15 pi upon 2. Therefore perimeter now can be calculated 2a plus b, which is 2 18 upon, so this is actually root pi here, 18 upon root pi plus 15 root pi upon 2. So if we take 3 out here as well as root pi, we would be left with 5 plus 12 upon pi. And therefore, A is the correct answer here. Okay, looking at the next question, we are given here, in a group of people, 28% of the members are young. So let's say Y is 0.28, while the rest are old. So old is 0.72. 65% of the members are illiterates. So illiterates is 65, and therefore illiterates would be 0.35. 25% of the literates are young. So young and literates is 25% of literates, which means 0.65 divided by 4. This is 0.1625. Therefore, now then the percentage of old people among the illiterates is what we have to find. So if we know young and literates is 0.1625, then young and illiterates would be young minus young and literates. So this is 0.28 minus 0.1625. So this will become 0.1175. And now we know old and illiterates will be nothing but total illiterates minus young and illiterates. Now illiterates total is 0.35 minus 0.1175. So this will come out to be 0.2325. The percentage of old people among the illiterates. So what we have to find here is old and illiterate divided by illiterate, which is 0.2325 divided by 0.35. So this will be 700. So if we calculate the percentage, it would be 930 upon 14, which is 66%. So C is the required answer. This is again not the exact answer, but that is the closest option which we have. Therefore, 66 is the required answer. Now here we are given an alloy is prepared with mixing metals A, B, C in the proportion of 3:4:7. Weight of the same volume of metals A, B and C are in the ratio of 5:2:6. Now if the same weight if we take the same volumes for each of the metals A, B, C, we are given the weights as 5y, 2y and 6y. Now if we have taken the weights as 3x, 4x and 7x, I mean these are the volumes, then what will be the weight? We simply multiply these two rows to get the weights for the different components. So this is 8xy, this is 42xy, and therefore the total weight here is 65xy. Now in 130 kg of alloy, what will be the weight of metal C? It will be 42 upon 65 of the total weight, which is 84. Therefore A is the correct answer here. Now, a gentleman decided to treat a few children in the following manner. He gives half of his total stock of coffees and one extra to the first child. So, after giving to the first child, he'll be left with 0.5 times initial X minus 1. And then half of the remaining stock along with one extra to the second. So, again 0.5 times minus 1 and so on. His total stock exhausts after he takes care of 5 children. Then how many toffees were there in the stock initially? So let's look at it from the backward point of view. Let's say for the 5th child, we know that 0.5k minus 1 is equal to 0 because he is exhausted after the 5th child, and therefore k will be equal to 2. Similarly, for the 4th child now, we get k equal to 6. Similarly, we keep doing this process. So 6 plus 1 into 2 is 14. Then 14 plus 1 into 2 is 30. And 30 plus 1 into 2 is 62. That is what we had initially. So 62 is the required answer. So we repeated this same steps 5 times to get the required answer. Okay, question 26, the last question here. We are given a solution of volume 40 liters has dye and water in the proportion of 2:3. So obviously we have 16 of dye and 24 of water. Water is added to the solution to change the proportion to 2:5. So the water is being added here. Let's say X is added and the proportion is changed to 2:5. Therefore 80 equal to 48 plus 2x, and therefore x equal to 16. So the total now solution becomes 16 of dye and water is 40. If 1/4 of the diluted solution is taken out, how many liters of dye must be added to the remaining solution to bring the proportion back to 2:3? So we have to take out 1/4 of this particular solution. So we take 1/4 of each of the components, and therefore we'll be left with 12 of this and 30 of this. Now we are adding some y liters of dye, and therefore 12 plus y upon 30 is equal to the new proportion. And therefore 8 is the required answer here. So that is it from this particular solve.